Chapter 2, Section 3. We're going to evaluate formulas and solve for a variable. This section will really force you to understand a lot of things about the rules that we can apply, like our multiplication and addition principles. But also it's going to do some things about working with fractions that I suspect that some of you students are just pulling out calculators and doing divisions with fractions, and when we get into this kind of work, that may not work for you. So, but let's go through there. What is a formula? Basically, a formula is an equation with defined variables. Um, and what I mean by defined variables, they have, like in this probably real famous formula of Einstein's, which is energy E, capital E here, equals the mass times c, which is the speed of light squared. Now the speed of light is a big number. I mean, it goes very fast, and when you square that, we're talking about a very, very large number. And the speed of light, for most practical terms, is a constant. But according to Einstein, not necessarily true. So, but yeah, we have this formula, okay? And they're just showing this as an example of a formula. And in the Newtonian, or excuse me, the Einsteinian physics, a large amount of this is based on this formula right here. He said if mathematically, if this is true, then there's going to be some really big explosions if we start breaking mass apart. And thus we ended up with nuclear energy and nuclear explosions, really, which is nuclear energy too, is hopefully just in a more controlled environment, trying to control the release of that energy. So let's look at this example one, which is an event promotion. Event promoters use this formula of P equals 1.2x all over S. To determine the ticket price P, that's what the P represents, for an event with X dollars of expenses and the anticipated ticket sales, or number of tickets that will be sold, which is S, they use this formula to determine what the ticket price should be. Okay, so, and I'm pretty sure not everybody does it this way. So if we had, in this case, in this formula, they say, well, if we think that the grand events expected expense for the concert is $80,000, that would be my expected expense for X, and anticipate on selling 4,000 tickets, which would be, sometimes a venue, maybe there's only 4,000 seats and they think they're going to sell out. What should the ticket price be? So they put the numbers that they know in for the variables. So they take 1.2 times that $80,000 expense, and they divide it by the 4,000 anticipated ticket sales. So they come up with P is equal to $24. Well, this formula is in a form that they usually probably will use to determine the price of a ticket. Well, there's going to be a lot of different formulas where we may want to solve for different variables, because we're not going to look for necessarily the price of the ticket. Like I might get a situation here where I'm not sure, I know what I want to set for a price of a ticket. I know what my expenses are, and then I might use that to say, well, under that model, how many tickets should I sell to fit that model? And that'd be a good way to test that. Well, let's look at this one right here, which is circumference of a circle, which means the distance around a circle. The formula is C equals, C, capital C is circumference. Remember, distance around is 2 pi r. 2 times this number pi, which is a irrational number, and so that's why they use a symbol for it. And r is the radius of that circle. So if I want to find out the circumference of something, which makes sense, it's a lot easier to measure from the center of a circle to the outside of the circle than to have to measure and walk around that circle or lay out some kind of rope or some kind of thing as accurately as I possibly can and then stretch it out and measure the length. This formula always works. In fact, it works because pi is generated by some things we're going to talk about here in a little bit. So I could solve the formula for radius. If I know what the circumference is, and they're talking about this, if I do know what the circumference is and some other things, and I want to figure out what the radius of that circle needs to be, I would solve this formula for r. So the circumference of a circle here is this formula. It says solve for r. So in other words, I want to say, well, I want a formula so when I put the circumference in, it'll kick out the radius of my circle. So we want the r to appear alone on one side of the equation and not appear on the other side, or we want something equal to r. So what they do is they start working with fractions. They show division here. I would prefer that you use the reciprocal of 2 pi. Now 2 pi is actually a real number, but like I said, it's irrational, so we have no way to represent it accurately or exactly. So we end up with estimations for that, or approximations for that, and stuff like that. That's why, again, why they use that symbol. And if it was, like if I used an approximation for pi, like 3.14, this would be circumference equals 6.28 times r. Well, if I thought about solving for r now, what would I do to that 6.8? I would divide by that 6.28, and divide both sides by that. If I put numbers in here, usually you kind of understand this, but if I understand the process that I go through, like really what I want that 2 pi to turn into is 1. I could do that. When I start thinking about that way, I don't necessarily think about division. I should think about reciprocals. And the reciprocal of 2 pi is 1 over 2 pi. And dividing by 2 pi is the same as multiplying by the reciprocal 1 over 2 pi. And I've said it a lot of times, I would rather deal with multiplication, because if I need to change the order of anything, or if I need, which is a commutative property, or if I need to change a grouping of something, I can do that, which is the associative property, if it's all multiplication. Once I mix divisions in or subtractions in, I am limiting myself because I can't apply those properties to it. But this process of solving for r is basically I get 2 pi r over 2 pi, which simplifies this fraction. Another way to think about this, simplifying fractions, is I end up with 1 times r, which is r. And then I have circumference over 2 pi. So if you give me the circumference now, I can put it into this formula and I'll tell you what the radius needs to be. And so if we can see how solving a formula is just like solving an equation. So they go through the process again to show you that, here's some things we've been doing with the last two sections, especially section 2 here, is I have addition principle they use first by adding -2 to both sides. I end up with an equivalent equation of 5x equals 10. And then I end up with taking 1/5 times both sides, and x equals 2. That's the way I'd prefer to say that rather than showing these divisions. Well, here's the same thing again, right? But here they don't simplify the math each time. They leave the numbers the way they are, and they do the same thing as they subtract 2 or add a -2. They leave it that way, and then to get this 5x to be x, I need to take it times 1/5, and I'd end up with 12 minus 2 all over 5. Well, 12 minus 2 is 10, over 5 is 2. It's just kind of like you hold off doing the math that you can do till the very end. Now look at this process here, and let's compare it to when I have just variables. If I want to solve for a in this case, or x, excuse me, is I would do exactly the same kind of steps. I want to get rid of this addition of b. I add its additive inverse to both sides, and I add a negative b to both sides. And then I want this multiplication of a to go away, so I take the reciprocal of a times both sides, and I end up with this c plus negative b all over a. 12 minus 2 all over 5. 5, 2, 12, right? A, B, C. Notice the pattern that comes out. So we're really not doing anything differently. We're not applying any new principles. We're just applying it to things where there are just variables that we're dealing with and not necessarily doing the math as we go through this. Now motion is a big formula that's used a lot. And the rate R, well, rate really means fraction. Ratio, and when we talked about the definition of a rational number, ratio and rational, right? The word ratio is in there. Ratio means fraction. Rates are fractions. Usually a rate has the denominator of 1, but it is still a fraction. So they're saying a rate of motion is distance divided by time. So if I'm going a rate in my car, a lot of times it will be 60 miles for a distance over 1 hour. 60 miles per hour. That is a rate, okay? Well, I may get into a situation where I'm going to know what the distance and the rate that I'm going to travel, and I want to know how much time will it take. Well, I could pre-solve the formula to fit what I'm looking for, which is time. So here's the process of solving this definition of a rate to this formula basically for t. So they go through this process of saying, well, let's get rid of the denominator. So they multiply both sides by t, which is okay. I'm following the rules. I'm doing the multiplication principle. And what this does is clear this fraction of t. In other words, this strategy would be something that we talked about, which would be, hey, let's clear our fractions. Would be a good strategy sometimes because I can multiply both sides by the same thing. Well, in this case, they decide to clear the fractions. So I end up with r times t equals d. They go through all this process. They remind you that we simplify fractions by rewriting them, and we can make fractions equal to 1. I can make this t over t equal to 1, which is 1 times d. That's how they get to d here. So now I have r times t equals d. Well, I didn't want to solve for distance, but if I did, I'm done, right? I just say, well, if I take rate times time, that'll tell me how far I go. So if I went for 60 miles an hour for 2 hours, I'd go 120 miles. Okay? Well, they really want us to solve for t, so we need to continue. This isn't solved. Well, how do I change this multiplication of r to a 1? Because 1 times t is t. That's what I'm trying to get to. So I use the reciprocal of r and multiply by 1 over r times both sides. They say division, which amounts to writing it exactly the same way. But this is really multiplying by the reciprocal. And again, I like multiplication because if I need to, in this case, I don't have to worry about it, but if I need to, I can use the commutative and associative properties as long as I stick with division or multiplication. So now I have a new formula for time. So if I want to know the time of something that's going to happen with motion, I take the distance and I divide it by the rate. So if I went 120 miles at a rate of 60 miles per hour, it would take me 2 hours. Okay? So solving these formulas follows all the same rules, and we go through that process. Let's look at example 4. It says there is one term that contains a y, so we begin by isolating the term on one side, and this is a very common thing we're going to run into, especially in chapter 3. We have a new kind of formula here. This is called a linear equation, and the solutions, and actually there ends up to be just like these formulas. I can't say solve this and say solve for t and say, oh, t equals 2, right? Like we've been getting on that. It's not a conditional equation. It really depends on all this. I have an infinity of things can happen with this formula. I also have an infinity of solutions to this formula, because if I put a certain number in for x, it's going to affect what number I need to put in for y to make it equal to 10. Now I can find the numbers to do that, and it creates a relationship between these two values that I substitute in for the x and the y. It's called an ordered pair, and it creates a coordinate plane, and we end up showing solutions to these things by graphing lines. So anyhow, they want us to solve for y. Well, the first thing they do is say, well, let's get rid of this addition of 3x by adding negative 3x to both sides. Now, probably something I would do right away is write this as an addition, because I see a lot of errors around. When this 3x changes to 0, 0 minus 4y is not 4y, it is a negative 4y. But also I could write this as 3x plus a negative 4y equals 10, and usually I don't ever see errors happen with it, reminding us that we have to have a negative 4y here, and don't accidentally drop that negative symbol, because that is a big deal. Well, by adding a negative 3x to both sides, I get to this. Well, how do I get this negative 4 to turn into a 1? Well, I use the reciprocal of negative 4. Now, reciprocals, the definition of reciprocal again is when I multiply a number times its reciprocal, I get 1. Well, when I have a negative 4 or a negative anything, the reciprocal is going to end up to be negative, because I need negative times negative to get a positive number, which needs to be a positive 1. So, and I need it to be the reciprocal to make it 1. I also see a lot of errors around this, as we forget that it needs to be a negative 1/4 times negative 4 to get to be 1 times y. Well, and then I multiply. Remember, we have to do the distributive property. When I do multiplication, I have terms over here. I need to distribute that multiplication over these two terms in this case. So you take negative 4 times 10, and you'll end up with negative 5 halves. I would pre-simplify as I'm multiplying, but they write the negative 10 fourths here just to make sure you see where the distributive property is going on. And then I take negative 1/4 times a negative 3x, and I get a positive 3/4 x. So here is a solution for y, when y is equal to this equation. And like when we get into chapter 3, this is called the slope-intercept form, which makes things easy to graph. So we're going to solve for y a lot of times. Now each example has a little more basically involved strategy really on dealing with how to solve these things. So in this case they have this formula for nutrition, which is K equals 917 plus 6 times the quantity of W plus H minus A, where W is the weight in pounds, H is inches tall, A is the age, and K, what we're looking for, is the number of calories needed for each day for a moderately active woman in this case. They create this formula. Well, we want to know what the weight should be for this situation for a moderately active woman, which is probably a real key way to do this formula, because that's one of the probably major ways we measure our health is by weighing ourselves. So we want to solve this formula for W, weight. And they start writing this out and they say, well, we want this W alone. I would just say I want something, the W, to be equal to. Well, they start doing some things here, and you really think about the strategy again, is that they subtract this 917 first, or add a negative 917 first, and this goes to 0. Well, think about this strategically, what's going on here. Well, 0 plus 6 times this quantity W plus H minus A ends up right here as just this. Hey, I'm getting kind of closer to making this simpler. Now, a lot of times we say, well, we should distribute. Well, I don't really need to do that. If I take 1/6 times 6, that turns into a 1. I don't have to distribute. And that's what they do here. They say dividing both sides. I'd say taking the reciprocal of 6 times both sides. By changing this multiplication from a 6 to a 1, I don't have to distribute anymore. I really distribute a 1. And I end up with k minus 917 all over 6. Well, now I still not done, because it's not W equal to something or something equal to W. So I do the addition principle, because all I have here left is addition. Even though this is subtraction, that's really plus negative A. So I add a negative H and a positive A to both sides. This goes to 0, this goes to 0. W plus 0 is W. And then I have to do that addition of A, the additive inverse of negative A, and the additive inverse of negative of H, which is negative H. So here is a formula for weight. So now if someone comes in and they say that this woman says she's 5'10", she's a moderately active woman, and this is the amount of calories that she is eating in a day, and her age, it'll come out with what you're going to look like for weight. Okay? So that process of solving the formula for a specific goal and what you're going to do with that. So let's look at this strategy box really. To solve a formula for a given variable, if the variable for which you are solving appears in a fraction, use the multiplication principle to clear fractions. 2. To isolate the terms with the variable for which you are solving on one side of the equation. Notice that, we had a couple where the thing we're solving for ends up on the right side of the equal sign. When I see students flipping their equations a lot, it really tells me, usually means, is that you're trying to memorize some techniques. You really don't understand the process, so you're just manipulating equations, trying to get to something that's familiar looking, so you can take and apply some memorized example. If you're doing that, that's going to be a problem, because it's going to be very difficult to memorize all the different strategies you could use to solve equations. So they talk about isolating here. Notice, like I said, it doesn't talk about which side of the equal sign you're on. If two or more terms contain a variable for which you're solving, factor the variable out. In other words, use the distributive property. Number 4, multiply and divide to solve for the variable in the equation. So let's look at example 6, the surface area of a right circular cylinder. The formula is A equals 2 pi RH, which is 2 pi times the radius times the height, plus 2 pi times the radius squared. Really what this is the surfaces of this cylinder right here. This surface on the top is a circle, and the area of a circle is pi r squared. Well, I got two circles. That's why they got 2 pi r squared. I take the area of this top circle and the area of this bottom circle, and I add those together. I'm going to get 2 of them. The surface of this cylinder is a little trickier to see, but if I cut a line, and I cut this like it was a label on a can, if I pull that off and didn't tear it, and I rolled it out, and basically I'm going to have a rectangle. Well, that rectangle is going to have one side be the height of this thing. What's this other side is going to be this unrolled portion of the top, which is the circumference of this circle. And that's where they get this 2 pi r, which is a formula for the circumference of a circle with a radius of r. And then they take it times the height. Well, this is the area of that rectangle I'm talking about that rolls out like a label of a can. Well, that's how they get the formula. So when we want this, they want us to solve for pi, which is kind of odd because we should know what pi is. It's a constant. It's just an irrational number. But we could take this, and let's say if we want different approximations of pi, I could test that against these by using the surface area of a right circular cylinder. Well, I have a common pi symbol here. It's just like a variable. I can factor that out. Now I could factor some other things out like 2. I could factor out an r. But what I'm trying to do is strategically I need to know what I'm trying for here, which is I want the pi to be equal to something. So all they factor out in this case is that common factor of pi. They use the distributive property and they rewrite this as pi times the quantity of 2r plus h plus 2r squared. Check that. Make sure that whatever you did when you factored, I can multiply this out by using the distributive property. Would I go back to this original expression? Now I have a multiplication of the thing that I'm trying to solve for, pi, times this grouping right here. Well, how would I get rid of that grouping on this side? Is I take the reciprocal of that whole thing, or 1 over that, where they talk about dividing by this thing. But basically they say here, I really appreciate that they do say this is multiplying both sides by 1 over 2rh plus 2r squared. And when I do that, this portion goes to 1. Pi times 1 is pi. That's what I'm trying to do. And then over here I get a over 2 pi rh plus 2r squared. Now they say, hey, you know, sometimes we usually flip it because we're used to seeing the thing that we're trying to solve for on the left. That's fine. But as far as I'm concerned, you can leave it this way too. What? Look at the glass. What's in there?
Don't pour it out.
What is it?
See it?
It's a bug or something.
Yeah.
What?
I found 2 of those in less than a minute, resting on my bed.
Where are my glasses?
I know I've seen them before. I don't know where, but I have. I searched up a picture of a bed bug. Bed bugs are more of a brown color, and I didn't see anyone with patterns.
They're a lot smaller too.
Yeah, and the ones that I saw with a pattern were carpet bugs or whatever. But they seemed more light than dark. So I don't know what it is.
It's like a beetle or something.
It's just kind of kills it.
It flies too.
Yeah.
That's not a bed bug.
Oh my gosh.
That's the ink from it.
Okay. I don't know, I just think it's really concerning that there are 2 right next to each other. They must be like laying eggs or something.
Do you have a screen in your Your windows?
Yeah. It could be a hole, and it could be the reason I have this, because it doesn't really seem like a spider bite.
Yeah, there are a lot of different kinds of bugs. I don't think that's a dangerous one, no.
And
I'll take a glass of water with some ice would be great. No. Mhm. Now they have a caution here too. It says if we have performed the following steps in example 6, it would have not have solved for pi, right? Is it's easy to say, well, I'm going to isolate one of these pi's, but to get one portion of that out of these terms, or basically one factor, I need to use that alone. And this is tricky. You could really realize that. So when we get into these places where we were trying to solve for something that has in the terms a common factor that involves what we're solving for, we need to deal with that first. And again, that's strategy, definitely strategy. And the test would be that we end up with like this, hey, I got it solved for pi, but I have pi in the other side here, so I'm not really have a good solution set up. Okay? So a lot of stuff that's, if you're not clear about the fractional parts and in the principles, and you kind of tend to memorize math portions of that, boy, when you start throwing a lot of variables out there, it really kills a lot of the memorized techniques. So hopefully you're going to learn the right ways to do this and the right reasons why when you go through problems involved with solving formulas.